Hello. So in this video, we are going to be going over another example of verifying trigonometric identities, wherein we show, using various identities from our knowledge of trigonometry, that two sides of an equation are clearly equal to one another. So we have that the square root of 1 plus sine of theta divided by 1 minus the sine of theta is equal to 1 plus the sine of theta divided by the absolute value of the cosine of theta. So there are a couple of things that we want to get rid of here. For one, the square root thing is not really comfortable to have in our equation because we don't know a lot of trigonometric identities involving square roots, and we don't really want the absolute value in there either because that also seems kind of tricky. So we can actually get rid of both of those by squaring both sides. So we're going to have 1 plus the sine of theta divided by 1 minus the sine of theta is going to be equal to, I'm going to write it out as 1 plus the sine of theta, not squared, but times 1 plus the sine of theta. It is 1 plus sine theta squared, but I think that this format will make things a little bit more obvious. And then divide by, now we have the absolute value of the cosine of theta, and we're squaring that. So we can ignore the absolute value because any squared value is going to be positive, so it serves the same purpose. So we have divided by cosine squared of theta. All right, so what is our next step going to be? Well, I'm going to multiply both sides by 1 minus sine theta. So we're going to have 1 plus sine theta is equal to 1 minus sine theta times 1 plus sine theta divided by the cosine squared of theta. Oh, wait, we forgot one. Times 1 plus sine theta. We have to remember both of those. They're very important. All right, so now you'll notice 1 minus sine theta and 1 plus sine theta. If you remember algebra 2, that's going to be the difference of squares. So we're going to have 1 plus sine theta is equal to 1 minus sine squared of theta times 1 plus the sine of theta, and then we're dividing that all by cosine squared of theta. Now here's a trigonometric identity. The Pythagorean identities say that 1 minus this here says that 1 minus sine here, that's not really a helpful color actually, I'm going to switch to something else. This here, I'm going to kind of circle this in red. We know that that is going to be equal to the cosine squared of theta because sine squared of theta plus cosine squared of theta is equal to 1. Therefore, cosine squared of theta is equal to 1 minus sine squared of theta. So we can just plug cosine squared of theta in for that. So now we have 1 plus the sine of theta. It's actually kind of a darker blue than I had before. Let's turn that up a little bit. Is going to be equal to cosine squared of theta times 1. I'm going to draw a little wall between these just so that's clear. Times 1 plus the sine of theta divided by the cosine squared of theta. Now you'll notice these cosine squared are going to cancel out, so we're going to have 1 plus sine of theta is equal to 1 plus sine of theta, because these cancel out. Notice both sides of the equation look identical, therefore it is clear just by the reflexive property of equality that these two expressions here, the top, are indeed equivalent. And so we have demonstrated, we have verified this trigonometric identity here. We're going to be going on to some more examples in the next videos. Thanks for watching.